channel points. Hello.
Gonna hit the ground running, baby, I'm running, baby, I'm running, 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 just as fast as I can. Gonna hit the ground running, just as fast as I can. Gonna hit the ground
Alright. So, is school back on? Well, looks like it is. Okay, so this morning's school wasn't on. But, so let me just tell you what's gonna happen the next 2 weeks. We're going to go over 11.5 and 6 with the 2 weeks. And we're gonna do 5 and 6 together. So it's gonna be a little bit of 5, a little bit of 6, a little bit of 6. But your homework this week is gonna be slowly on 11.5, and next week slowly on 11.6. So if you see something in 11.5 that we didn't talk about in class yet, that's fine. You can go ahead and try to see if you can get something out of it. But the next week's homework should be all covered, okay? So the reason why we're doing that is because I think it makes sense to talk about 11.5 and 11.6 together. You'll see. Okay, so let's get started. So today we're going to talk about volume, and this first thing we're going to talk about volume is law of prism and cylinders. So that's first thing in 11.5 we're talking about. So we're going to calculate volume of prisms and cylinder. Now, why do we hold on, 13, 20. Okay. So, why do we talk about them together? Well, because cylinder is a circular prism, right? So, like, for example, a prism is when you have a base on top, on bottom, and when you are looking at it, each part of the cross section is exactly the same shape, whereas cylinder is the same thing, but it's just circular base. Okay, so what are we doing here? Volume is base times height, but this base is in big B, right? Big B stands for base area, okay, times height. Why is it base area times height? Well, think about prism as, you know, prism has two bases, one on the bottom, one on the top, but it's uniform throughout the whole shape, right? What does that mean? It means it's kind of like a sticky note. You have sticky notes or post-it notes. They're kind of like an example of prism where you kind of stack layer by layer, right? And each of the layers are exactly the same polygon as your base, right? So how do I know what the volume is? You figure out how many stacks you get. Well, how many stacks did I get? I multiply by the height, how high this thing is, okay? So that's why it's base area times height, you get a volume. Some special cases is a rectangular prism or a cube. Rectangular prism is the base area is a rectangle times height, right? So rectangle base area is width times length and times height after you get the base area. So it makes sense that will be length times width times height. Okay. For cube, is s cubed. Why? Because no matter which base you pick, they're the same base, right? S squared times s. Okay? All right. If that's fine, let's look at an example problem. Find the volume of the rectangular prism. Notice that this is slanted, right? But they tell you the base is rectangular. This part is slanted, so the base must be here, right? Otherwise, so it would be volume equals base area times height. Okay? So base area is obviously 3 times 4. Right? 3 times 4. The height, 1.5 feet. So together is 18 feet cube. Okay? Make sure you get this cube in because it's 3-dimensional. We are doing a 3-dimensional calculation. Okay? Alright, so next one is a hexagonal, right? It's a regular hexagonal. So that means the base is a regular hexagon with 9 feet side length. Now, that's the base, right? That's the base. So in order to get base area times height, you need to find the base area. Remember how to do this? This is from a few sections ago, right? We were doing regular polygon area. This is a good time to review. Okay? I'll give you some or actually, can you tell me, type in the comments, how do I calculate the area of a base that is a regular hexagon? Google, no. One half a p, right? Okay, so what we did before was we cut into triangles, right? Remember that? And we took out one triangle, and we find the angle first. The angle here is 360 divided by 6, so it's going to be 60. But we need to get, remember, we need to get the apothem. So this will be 30 degrees. And this was 9, so this is 4.5. Right? And then we set it up like tangent 30 degrees, right? Opposite and adjacent. Opposite over adjacent. Okay? So A, solve for A. Turns out it is what? What do you get A for? Apothem. It's 4.5 times root 3. So be 7.794. Okay. The other way to do this is 1 root x root 3 and 2x, right? Because this is a 30, 60, 90 right triangle. So that's why I say this is 4.5 times root 3. but you can also use tangent because tangent works for any right triangle, right? But it happens that this one's a 30, 60, 90 that we can use. Regardless, A would be 7.794. Okay. Then what do we do? Calculate area of a triangle, right? So it's 1/2. So base area is equal to 1/2 base 9. Height is A, which is 7.794. All right. How many do I have? I have 6 of them. So times 6. Okay. So base area turns out to be 210,444, something like that. Okay. That's base area, right? Then the volume will be base area times height, which is 210.444 times 12. So that would end up being it's right here. Point 3. Okay. Feet cube. All right. So feet cube, going feet cube. This is feet square. This is feet square, right? The base area is feet square, but since you multiply by one more height, you get feet cube. Okay. All right. Any questions? So you gotta remember how to find base area of this first. So that we already talked about before. And the extra part today is just to multiply by the height. Okay? That's the only thing. Okay? If you understand how to do this, then it should be no problem. Okay? If you forgot how to do the base area, then why do we use tangent? Because we want to find the apothem, which is the height of this triangle, right? Height of this triangle. And we know this is 30 degrees since this whole thing is 60 degrees. So we want to know this part. We have the opposite side. We want to know the adjacent side. So tangent 30 is opposite over adjacent, right? Because you have opposite and adjacent available to you. That's why you want to use tangent. Does that make sense? Alright, so let's move on to the next part. So, the next part is a square base. It didn't say, but it's a square base. Okay, it's a regular square. Okay. Now, so basically to do this, this is hollow inside. Okay, hollow. So we're gonna use the cylinder minus the rectangular prism. In this case is a square base prism. Okay, we're gonna do that. Okay, now to get this volume, this is a base area times height, right? But how do I get base of a circle? Base area is pi r squared, right? Pi r squared. So we're gonna do pi r squared. Pi r is 3, right? Radius is 3 square times height is 5. Okay, so that part is fine. Subtract. Now, if you look at this, okay, I'm going to look at this square and take a look at what we're given here. Okay, square here. And they tell us this part is 3. Okay, notice that the side length is not 3. This part is 3. Okay, so we're going to use a similar method, which is cut into, because we didn't get the base, which is what we really want. Okay, so if you use this, you can find the area by finding the third side. You can either do that, or because this is a regular polygon, we can use the fact that this is 4 triangles. Each part will have to be a right angle, right? So you can use Pythagorean Theorem to find the third side. That's also possible. Or you can just use the other formula we use, 1/2 AB sine C. Right, remember that? That's an area formula. I'm going to use that and then times 4. Okay, I'm going to find one triangle and I'm going to times it by 4. Okay, so area is 1/2 AB 3 times 3. Okay, 1/2 AB. Sine of the included angle is 90 degrees. Okay, so that's one triangle. I have 4 of them, so I multiply by 4. And then I will multiply by the height, which is 5. Park, you can use any 2 triangles in any type of way you want, as long as you get the area. The problem with using 2 triangles is that you still need to find these lengths, right? So regardless of what you do, you have to choose your own way of finding area. Okay, you just can't use this 3 as base. Okay, that's bottom line, because if you use this 3 like this, then you won't get the right answer, because your 3 is a diagonal, right? 3, 3, so 6, 6, basically. So yeah, you can choose your method of how you want to find area. You can find the third side, then find the apothem, and then do the area. Or you can use my method, which is 1/2 AB sine C, 1/2 3, 3 sine included. We use this a lot, right? In recent ones. Right? You can use any method to find area, okay? As long as you feel convenient. So, after you do that, calculation, what do you get? I got 51.4 centimeters cubed altogether. Okay. How are we doing with this? So same thing as previous one. You just need to find it. Yeah, you're right. And round to nearest tenth, right? So it will be 51.4. All right, so you try this one. This one should be much simpler because there are 2 circles, right? Let me know how you get this one. Thanks very much. All right. Did we get an answer? Drop the bombs, guys. After close calculation, okay. So in your mind, this is hollow, so you gotta subtract this part out, okay? So this part is pi r square times height, right? Base area is pi r square times height, which is 12, minus pi, wait a second, I think I did it wrong. This is 18, right? 18. Okay. Minus, same thing, but the radius is now 9 because the inside part is 9. Square that out. Subtract. I think you guys who typed the answers are correct. 9160.9 inches cube is correct. Okay. Comfort level 1 to 10. Does make sense? Doesn't make sense at all. Give me a number. Okay? Give me a number. 1 to 10. Oh, for the first one? So, the first one we use AB sign because look at how your triangle is formed, right? If you look at your triangle, I'm given these two parts instead of the base, right? So if I'm given two sides and an angle in between, then we can use that formula, right? AB sine A, 1/2 AB sine C. That's for the situation where you have an include angle, side situation. You can find the area that way, okay? But if you're given the base, like how we did in the problem over here on top, the hexagon problem, if we have the base there, then we need to find the height, right? Because base times height divided by 2. That's the area of a triangle. But if I use 1/2 AB sine C, I don't have to look for the height or the base. Okay, that's just a way I choose a method that I can use like that. However, the alternative would be, okay, instead of doing that, since I know it's a square, it's a special shape, right? And this is a right angle, we can use Pythagorean Theorem to find the third side. And once we found the third side, it's basically that base times height. That's it, right? This times this, because these are all the same. So it's just a reminder of how many options you can have for finding area in different situations. You can always use your own method to find whatever part you want. If you want to find the apothem and the base before you do it, then here you have to use sine and cosine, okay, to do it. If it's not a right triangle, if it's not a right 90 degrees here, okay. But other than that, you can feel free to use any area formula you want. Does that answer your question, video? Cohen, why you get a 1? Cohen, ask a question. So, yeah. So the whole point of the volume is that So we go back to the fundamentals, okay? Because I think a lot of you know how to calculate it, but it sometimes doesn't know why you do it like certain ways. So fundamentally, when we want to find a volume of a prism, what we're doing is we are counting how much can I contain in this, right? So we count the area of a base, we know how to calculate that, and we multiply by how much there is on the height, okay? That way I can know how much of this area I can accumulate, right? Because volume by definition is how much you can contain, right? So you find out how much you can contain in the 2D space, and then multiply that out by depth. And since they're all the same shape, you can pretty much just times this by however many. Okay? Now, how to find area of the base depends on what shape of the base it is. If it's a square, then you can use square. If you use a hexagon, we already talked about how to find a hexagon, a regular hexagon base area, right? That's from the previous section. The circle, then pi r squared, right? So they're all the same idea. You just find the base area and you times by height. Alright. So if we're okay, then let's look at the next page. So the next page is this, 11.6. This one will be quick. We're talking about pyramids and cones. Okay, pyramids and cones. So pyramids and cones is very similar to prism and cylinder, except there's only one base, right? The other end will converge to a point, so it'll have a pointy end. Therefore, just like how cylinder and prisms are similar in terms of how you find the area, volume, base area times height, right? They're all the same in that it's 1/3 base area times height. Why is it 1/3? Because 1/3. Okay, not 1/2. I'm gonna just cover the whole thing with my pen. 1/3. Okay, not 1/2. 1/3. Okay. Now, so objective would be find and calculate volume of pyramids and cones. Okay, this is still 13, right? Okay. So, if you look at this, we can safely say that a pyramid to prism, the relation, right, is the same thing as a cone to a cylinder. Do you agree? Does this make sense to you? A pyramid to a prism is the same thing as a cone to a cylinder. Do you agree with me? Does this part make sense? What? Yeah, well, the stream is delayed, so I'm waiting for a response. So if it takes long, I apologize. Regardless, anyway, so everything is gonna be there. And if you would like to know the proof of this, this proof is on page, let me see, 635 to 636. There's a sand experiment that they were doing in the book, so we can take a look at that. And they also have some sort of manipulation to the shape, which it's hard to explain on paper here. So if you're interested in the proof why it's 1/3 of the base area times height, then that's where you're going to be looking at. Okay. All right. So regardless, let's look at the example problem. So everything is the same, except your volume is 1/3 base area times height, right? So you still have to find the base area, and you still have to find the height. And here, they didn't give you the height, but they did tell you the height is equal to the apothem. And so once you get the height, then you'll get the apothem. Once you get the apothem, you get a height. Okay. Now, here we go. Next one. Okay, so find the base then. Remember how to find the base? Just tell me the area, just tell me the answer, what you get for the base. That way I don't have to. So it's the same thing as the previous one, right? Base area. Except this one is the 12. You get an answer for this one? Once you get the answer, type it up. Let me amplify a little bit. 30 degrees here, 6 here, and you want to find apothem, right? So apothem end up being, right, tangent 30 again equals 6 over A, right? So A end up being what? 10.392. Okay. All right. And then once you know that, you also know the height is the same thing as A, right? So we're just going to do base area is going to be 1/2 apothem, base times apothem, right? And then you have 6 sides, so you multiply by 6, which turns out to be what? 374.11. And you use this to plug into this, right? So 1/3 base 374.11 times height, which is once again 10.392, because they say the height is the same thing as the apothem. Okay, and then multiply it together. The answer would be 1295.9 feet cube. Okay. Does that look like the right answer? You try one. All right. Keep in mind that this is a equal out triangle, so you pretty much only have to do one triangle, because usually we cut into multiple triangles from the middle. But since it's already a triangle, we don't have to bother with that, because every length is given, right? You got 12 here, 12 here, 12 here, and you also know this height is 10. Okay. So after you find the base area, and after you find and then you find the volume, right? So can you tell me the answer once you're done? I give you 2 minutes. 2 minutes. You find the base area yet? 423. I think Patrick, what are you doing here? So 12, I don't think it's 423. Oh, you mean like the answer? The whole thing? I still don't think it's 423.9 though. Seems a little high. 207.8 sounds right. Royce, I think you're right. I think Vidya, you forgot to divide by 2 in your base area. So here, you can choose to find the height if you want. So, or you can do 1/2 AB sine C. I'll just do 1/2 AB sine C, okay, because I like that formula a lot. So base area is 1/2 AB sine 60. Okay, and that ended up giving you a 62 something, 62.353, something like that. And then you use volume equals 1/3 base times height, which is 1/3 62.353 times 10, which is 207.8 inches cube. Okay, inches cube. Does that make sense? So same idea. Still have to find the base area. So most of you would have problem if you have problem doing the base area. Okay. All right, last part. Last part is volume of cones. Same thing as the cylinder, except the base area is now pi r squared because it's circle, right? Circle. So this is very similar. So more composite figures here. Composite figures means two solids form a new solid. Sometimes you dig it out, sometimes you add on top of it. In these two cases, that you add on top of it. So can you tell me? Oh, they look symmetrical, but it's not symmetrical. Okay, gotta be careful finding the heights. You have to split these three, right, and then add them up. And in this case, what would be the area of this volume of the top? Volume of the top would be 1/3, right? Cone, right? Pi r squared. What is the height here? Well, the whole thing is 70. So that means this is 35, so this is also 35, yeah? We're okay with that? This is 40, so that's why I say they're not symmetrical. Okay? 21, and then times 35. Okay? Yep, you're right. You are right. 35 is correct. Then you do the next part. Next part is similar, except it's a cylinder, so there's no 1/3. Okay, just pi r squared times height. All right, radius is the same because you use the same base, right? The last one, pi r squared, but the height is 40 instead. And then you have to multiply by 1/3 because it's a cone. Yeah? Cone? Cone, cylinder, cone. Cylinder doesn't have the 1/3. Cone has a 1/3. Add them up. Add. Tell me the answer when you're done. What do you get? Jeremiah, very funny. 83,126.5 is correct. This is in centimeters cube. Okay. Cohen, I think it's because you rounded pi. Just put pi. Don't put 3.14. I think that makes a difference in this case. That's the reason why you're off by a few decimal points. Try this one. All right. This is the last problem. So while you're doing it, if you're here, please type that you're here so that I can take attendance real quick. Anyone spotted avia? I feel like I'm missing an avia. Yeah, I think I'm only missing avia and... Oh, hi, Olivia. Yeah, I'm just missing avia, that's all. So avia, if you're listening, either send me an email or comment or send me an email. I don't know. If you commented, I didn't see anything. Okay. So we don't have an answer yet. Top, what? 1/3 pi r square, 12 square, right? Times h. And yep, I think you're right, Chance. I think you're right. I think you're right. The base will be pi r square h, which is 18 square. No, 24 square. 24 square times height, 18. All right, add them together. Should get 33,929.2 yard cube. Uh, 1164. I think you're missing a It's more like 10,000. Oh, in terms of pi. Well, if it's in terms of pi, well, it's still not gonna be 1,000 though. It's more like 10,000, 10,000 something. So if you do it in terms of pi, it's 10. And I got 10,800 pi. Pi yard cube. So take a look. So first of all, you do. So since we're doing it in terms of pi, let's look at how many pi this is. This is a 1/3, right? 1/3 times 12 square times 9, right? So that's 432. And then the other one is, so we plus. The other one is, oh, you didn't divide by 4. Yeah. 24 square times 18. Right? Then you'll get 10,800. Okay? Or 10,800. Alright. Your homework is already open on big ideas. Alright? Homework on big ideas. Okay, it's due Sunday. 11.5, like usual. Okay. So if you you know, you should start ASAP so you can like get some sort of very funny, very funny. Wow. Okay, let's not get into this girl-boy argument, okay? We're all peace here. Okay? Alright. Any other things before I'll let you go? Okay. Well, of course, Jeremiah, of course. You know that's true. You are my favorite class, period, in quotation. Got it? Period. Yeah, so, nothing it seems. So I'll see you next week then. Goodbye. What is this music? I'm gonna switch one. Goodbye.